All right, here we go. Welcome to your acid and base notebook. We're starting at chapter 3 because your first two chapters will be just copying and pasting stuff. This is the first one we'll actually do some work on. Okay, this chapter is titled KW and pH. These things right here are the problems from the book, you know, the one that's collecting dust and cobwebs in your room. Those are the problems you will do to practice this type of problem. Okay, so KW, well, K is equilibrium constant, like we know already, and the W stands for water. So this is the equilibrium constant for water. It actually is going to stand for the autoionization of water, and we're going to calculate the pH of water. What do you know it is? You know it's 7 already, right? Pure water. So I'm going to prove to you where this came from, okay? Please note that this is at 25 degrees Celsius. So all of these numbers are when the temperature is 25 degrees Celsius, okay? So what does that mean? pH of water that's not at 25 degrees Celsius is not 7. We'll talk about that later, but for now, let's go with the major thing, okay? All of these problems, there will be basic steps that we'll do over and over and over again. So in your acid-base notebook, you'll write these out. You'll write out the word identify major species, write out the reaction, write out the equilibrium expressions, set up an ice chart, and you will start to notice you approach all of the problems the same way over and over. There will be some variations, but this will be a general outline over and over, okay? So I'm asking you to calculate the hydrogen ion concentration, the hydroxide ion concentration, the pH, and the pOH of pure water, and I probably should have added at 25 degrees Celsius, okay? So, major species means who are you trying to find? What are you looking at? What's involved right now? So, obviously, whoa, let's go back a little bit. Bear with me, I'm just learning still, okay? H2O, and we're also trying to find H plus species and OH minus species. But water is the main thing we're focusing on for pure water, okay? So here's the interesting thing about water. We talked about it, that water is amphoteric, meaning it can act like both an acid and a base to a certain extent. So when I write out the reaction of water molecules approaching other water molecules, one of the water molecules will act like a Bronsted-Lowry acid and donate a hydrogen, and the other one will accept it, okay? So, remember, water is not a strong acid or a strong base. It is weak, so we will write it to equilibrium, right? So let's say this water is going to accept a hydrogen ion. That will form what's known as H3O+. That's the hydronium ion. Plus, this guy takes the hydrogen, and this guy donates the hydrogen, okay? So, I'm sorry, if I misspoke, this is acting like a base by accepting a hydrogen. This guy is going to act like an acid and donate one. Well, when water donates a hydrogen, you end up with OH minus, okay? Well, what state of matter is water usually that we assume at 25 Celsius? Well, at 25 Celsius, water is going to be a liquid. Ions are always what state of matter? Aqueous, always. Sorry about the ugly writing, okay? So this is called the autoionization of water, okay? Just so we remember, H3O+ is often interchangeable for the sake of our course with H+. It means the same thing for the sake of our class, okay? So, when we go to write out an equilibrium expression, remember, it's K equals products over reactants. So, K equals products. So we've got H3O+, also known as H+, which is how it is written on your equation sheet, and OH minus, over, well, nothing. Water is a liquid, so this is the expression. Now, I'm going to put a W here because this is special for water, okay? And now, this is also on your equation sheet. You don't need to memorize this. The KW is a constant. It is an actual number at 25 degrees Celsius, and it is 1.0 times 10 to the negative 14th. Okay? H plus OH minus equals 1 times 10 to the negative 14th. This will always be true if you are at 25 degrees Celsius. And I will be honest with you, 99.99% of the problems will be at 25 degrees Celsius. So this will be your setup every single time. So what does this mean? This means at any point in a reaction or whenever, if you know the hydrogen ion concentration, you can figure out hydroxide because this is what K is. If you know hydroxide, you can figure out hydrogen ion because this is what K is. You can rearrange to solve for one of the three variables if you know two of them. And you will always know this because it is always this number at 25 Celsius. Okay, so now what we're going to do is when K is given, remember we set up an ice chart. So I'm going to go back to my reaction. Water bumping into another water molecule to form the hydronium ion and the hydroxide ion. Okay, ICE. Now, here's the deal. Waters are liquids. We don't care about them in an ice chart, just like we don't care about them in an equilibrium expression. So I'm going to ignore them. Okay, my products. Technically, you should not have any products at the beginning of a chemical reaction. So now what do? You set up an ice chart. You have to let X equal something. I'm going to have it be the hydronium ion because that's what I feel like. You could have just as easily picked the hydroxide ion at equilibrium. Okay, so X, that means I must have gained X here. Well, this is a 1-to-1 ratio, so I must have also gained X here. So this is X. Okay, now I'm going to have to switch to a new page, so bear with me. Okay, we're going to plug back into our equilibrium expression, right? So I have KW equals X for the hydronium and hydroxide. And remember, all of this equals 1.0 times 10 to the negative 14th because that is the constant for water at equilibrium and at 25 Celsius. So this is X squared, right? Equals 1.0 times 10 to the negative 14th. So what do we do to solve for X? X equals the square root of 1 times 10 to the negative 14th. Okay, now I need to teach you a cheating method because they will ask you to do this on the MCQ. To take a square root without a calculator. Are you listening? To take a square root without a calculator. If they ask you to do this, they will be nice numbers. You take the square root of the first number and you have the exponent. That is always the rule. Okay, so the square root of 1 is 1 times 10 to the negative, what is half of 14? 7. Why do you do that? Well, because square root is saying this is the same as raising it to the 1/2 power. Okay, so what is X? Well, that's hydroxide ion concentration and it's hydrogen ion concentration. You should note that in pure water, you should have identical amounts of hydrogen ion and hydroxide ion, and they are both 1.0 times 10 to the negative 7th molar. So I just solved for the hydroxide ion concentration and the hydrogen ion concentration, also known as H3O+. Remember, I'm using those interchangeably. Okay, that is their molarity, and they're the same molarity. That is why water is neutral. Whenever you have neutral water, the hydrogen ion concentration and hydroxide ion concentration are identical. All right, so now something interesting is you can go back to, I'm going to show you how they got this. The pH equation looks like this. pH equals opposite the log of H. Okay, pH opposite the log of H plus concentration. Okay, so if the H plus concentration is 1 times 10 to the negative 7, pH is opposite the log of 1.0 times 10 to the negative 7th. Now I will tell you something interesting about logs. Anytime this first number is a 1, exact 1, nothing else, not 1.2, not 1.1, exactly 1. Whatever your exponent is, that is your pH in positive form. So opposite the log of 1 times 10 to the negative 7 is 7, which is how you know water to be, right? pH is 7. Okay, watch. If this was 1 times 10 to the negative 8, the pH would be 8. If this was 1 times 10 to the negative 13, the pH would be 13. If this was 1 times 10 to the negative 10, the pH would be 10. Opposite the log of something with a 1, the pH is just whatever that exponent is if you're solving for pH. They will have you do that on the MCQ part. They expect you to be able to do that without a calculator. Okay? So, pH is 7. Well, let's go back to this equation. Kw equals H plus, or H3O plus, and OH minus. Alright? I'm going to take the log, or opposite the log of both sides. Opposite the log of that side, opposite the log of this side. The rule of logs will opposite the log of Kw, which is opposite the log of 1 times 10 to the negative 14, is 14. Okay? Opposite the log of two numbers being multiplied together is the same as opposite the log of the sum of their numbers. It's just a rule of logs. Okay? I don't need you to know that rule. I just need you to know that that's how they get this. OH minus. So it's like the sum of the opposite of logs of these. Well, opposite the log of H plus is known as pH. Opposite the log of OH minus is known as POH. So pH plus POH is 14. So how do you get POH? Well, if you know pH is 7, which we solved for up here, you take 14, you subtract 7, and I'm going to go back up here, I'm sorry. POH is 7. This is, again, for pure water at 25 degrees Celsius. A neutral pH of 7 at 25 degrees Celsius. So that is all for this problem. This is the very, very beginning of a really long but really thorough acid and base notebook problem.